We have Cedric here. He's been working with Android since the very beginning, all the way back in 2007. He's a senior Android engineer whose passion has taken him to leading financial companies and tech giants like Google. Today, he'll draw on that deep experience and explore whether Kotlin Multiplatform is the future of Android or not. So please give him a big round of applause.
Good morning, everyone. It's amazing to see the room so full and so many chairs. Today, we're going to talk about Kotlin Multiplatform and try to answer this question, and maybe you can consider using Kotlin Multiplatform in your next project. So thank you for the introduction, Kartik. I would like to go a little bit deeper. So yeah, 15 years of experience on Android. My favorite dessert is Android Jelly Bean. I worked for a long time in the banking industry, and I got the opportunity to work at Google for a few years. I'm also developing the Android Developer News app. So if you don't have it, you can download it on the Play Store, which help you guys to stay in touch with all the latest technology and trends on Android. And you know, there are a lot. So my journey with Kotlin Multiplatform started actually when I built that app. Back in 2020, there were two major things that were released. One from Google, it was Compose. It was announced at I/O 2019 and then released in 2020. So that was one of the technology I wanted to try and use. And then Kotlin Multiplatform Mobile at the time it was called, was in alpha around that same time. So I thought, oh, that's a good opportunity to create a new project and use both these technologies. So one of the reasons I wanted to do that is also because the view model were introduced, the view model architecture was introduced, and we had a lot of things to do with clean architecture, and I thought we can use the pure Kotlin layer that we can find with Kotlin Multiplatform, as we will see in a few minutes, and keep my Android things and use Compose for my UI. And I think one of the big reasons I wanted to bring this talk to you is because the popularity of Kotlin Multiplatform has really increased a lot in the last 2-3 years. It actually more than double. And you can see that every time there is a Kotlin conf, there is like a good spike. So at the top, you can see the Google trend of Kotlin Multiplatform, and at the bottom, Compose Multiplatform. Compose Multiplatform is a shared UI across Android, iOS, desktop, and web. So which means now we have tools to build application in a single code base and reach potentially a lot of customers. So let's understand a little bit what is Kotlin Multiplatform. So Kotlin Multiplatform is a sharing across device and across platform framework. It started initially for targeting kind of anything, including server-side, Android, iOS, desktop, and web. Today, we are going to focus mostly on the client side because I'm a mobile engineer. And we're going to focus only on Android, iOS, desktop, and web. One of the big reasons for that is because the stability of the framework has progressed a lot, especially in the last year. Now, both Android and iOS are considered stable by JetBrains. And so that offer the ability for developers like us to build with really one single code base. Web is coming as well. So we can think that in maybe the next year, we will have a truly single code base for all the platforms. And that remove a lot of headaches. Not only that, but for companies that want to be a little bit more profitable, they often turn to React Native or other technologies that doesn't have necessarily the same performance. Now with Kotlin Multiplatform, we have very similar performance as native with a very single code base. So let's look a little bit how it is organized. How can we accomplish that? And how it works is that we have a common layer, I would say, that is written in Kotlin and Compose. So Kotlin is for all your business logic, network calls, these kind of things. And Compose is mostly for your UI. And then you can address Android, iOS, desktop, and web. So let's dive a little bit deeper. A Kotlin multi-platform tech stack looks like this. You use Compose for your UI. For threading, you use Kotlin or coroutine. For persistence, you can use either Room, which comes from Android, or SQLite Delight. And finally, you've got network provided by Cato and dependency injection with coins. All these pieces you may or may not have heard before, but you probably know the concept anyway, because this is how we use it on Android for the most part. And with this, we can basically write once and run everywhere, which is probably one of the dreams of many developers who had wanted to deploy their apps and share their IDs and provide values to a larger number of people. So for Android developers, this is very appealing because it's using Kotlin, a language that has been here for a few years that we know and love. It's also using familiar libraries, including data store coming from Google and part of Android, Compose that has been trending a lot and has been heavily adopted by developers in the last 2 years. Room database that is also been here for years and provided by Android. And Coin, which is a dependency injection alternative that has been around for a few years, is gaining also a momentum. And finally, our code will be reusable. So I think this is something every developer wants. I want to bring a little bit of history here so we understand where we come from and where we can go. So back in 2008, 2012, we had very limited Android framework. It was based with Vue. For threading, we had async task, if anyone remembers that. For persistence, we had like SQLite, not even like a ORM. It was writing all the SQL queries and everything. And then we had HTTP client, very basic HTTP client, a lot of security flows at the time. Then Android started to be a little bit more professional. And then we saw things like RxJava emerging, which allow complex threading and complex flow of APIs, etc. Persistence, we still had SQLite with some projects starting to come. And for network, retrofit was introduced by Square. That was a big change for a lot of developers and also improving the security overall. And then also a new component, dependency injection, because as the apps were becoming a lot more complex, we wanted to simplify the way we can use modules here and there in the code base. So Dagger was introduced, also from Square, if I remember well. And then until now, and from 2016, so on top of Vue, Compose has been introduced. Google really commit on the MVVM architecture. For threading, a lot of people are using either RxJava or coroutine. For persistence, we have Room, which was introduced about 10 years ago. We still use retrofit very heavily. And Dagger became Hilt when it was like more handled by Google. So let's zoom in the current tech stack and understand how we can convert this 2025 tech stack for Android to like a Kotlin multi-platform one. So essentially, we have all of this that we just said, plus we have all the Jetpack libraries, right? We need like biometrics maybe, we need Firebase messaging to receive notification, Camera X to play with your camera, take pictures, localization for your maps. And that can be the part that we will see is a little bit more complicated with Kotlin multi-platform. But that said, we can, the basics are here. We've got Compose, multi-platform. It's stable, Android, iOS, desktop, and beta and web. We've got the MVVM that we all love. The coroutines, Room, provided by Google, so we don't even have to change the persistence layer. For network, however, there is Ktor. Maybe this is the first time you hear about Ktor, which is getting some trends, but it's not retrofit, so you may have to learn something here. And Coin, very similar to Hilt, but it's also a new framework. So if you look how close the two tech stack are, they are somewhat close. Basically, Ktor and Coin are the two things you need to learn if you want to move to more like a Kotlin multi-platform tech stack. That being said, what do we do with all those Jetpack libraries, right? Because you still need your biometrics, you still need your notification, etc., getting your geolocalization. So this is a gap that we need to fill. We need to find a solution for that. And this is really defining if it is ready for you or not. With Kotlin multi-platform, you can implement platform-specific code, which means if you've got specific APIs on Android or iOS, let's say the dynamic island on iOS, you don't have an Android framework for that, but you can build it in Swift and then have some bindings, and we will see that in 1 second. Or the second option, so you can build it yourself essentially, or the second option is you find a library that is already available and that does that for you across Android and iOS. The way it works, if you do it yourself, is you have to define what we call expect and actual. The expect is a code, you provide a interface, if you like. It's very similar to an interface. And you say, okay, I expect that in your native code, in your Swift or Kotlin code. And the actual is the actual implementation of that. So whenever in your Kotlin code you call the expect function, it's actually going to call the actual function and run the Swift or Kotlin code or whatever is API is specific. And the way it works is, again, you put your expect code in your command module. So the command module doesn't know really how it works behind the scene. And the actual implementation exists in the Android layer, iOS, desktop, etc. So let's see a small example. So because code speaks more, right? So on the left-hand side, you can see we have a command.expect.kt, and we expect to build a person. So this is just the function, and it has to return a person, right? And then in the Android code, you just implement that, and you provide the code, the actual implementation, all the data. This can apply for your camera, your geolocalization, etc. So instead of person, maybe you've got GPS coordinates. When you use it, you know that you're going to receive GPS coordinates. You don't know how it is built. It's very, very similar to an interface. Very similar concept. So this is if you do it yourself, but can we do better? Can we avoid to have to write all this code ourselves? And thankfully, the answer is yes. Like the number of Kotlin multi-platform libraries has been multiplied by 5 in the last few years. There are over 2,000 libraries now. And as you can imagine, a lot of these use cases that we just talked about, like camera or geolocalization, they are handled. And so how is it built? Actually, very similarly, it's just implementing what we just viewed earlier. It's using a expect and actual layer for each platform. The only caveat with that is some libraries are more focused on mobile, so they will only implement Android or iOS. And some libraries done like a more extensive job, and you can use that across every platform. So it's kind of up to you to check what libraries are good for what usage you want to do. So the good thing with this is you have got a single implementation in Kotlin. It fits most of the common use cases, and you can still access the platform-specific API. However, it may not cover all targets because the developer of the library decide what they want to target. And you may miss some advanced platform feature. The reason is because it is built for fitting across multi devices, multi-OS. And so sometimes one feature is not available in iOS, or sometimes one feature is not available in Android. Library maintainer try to do a good job with that, but you may miss some of the features. Some of the popular libraries, and you can see that cover a large range of use cases. We've got image download. So a lot of you may have used Picasso in the past. Coil is the new kid in the block. And it's like everyone is using it, even people who don't target Kotlin Multiplatform. For log, there's Timber. There's a lot of things for media. For database, we talked about Room earlier, which is supported by Google, but there is also SQLite. There's even things for Bluetooth, etc., etc. I use many of these libraries in my application for Android developer news. Recently, JetBrains has released klibs.io. It's a website where you can look for libraries. It's very useful. And so you can search by name, you can search by kind of component, dependency injection, camera, whatever. And what is very interesting is that you've got the coverage of the library. So for this one, for instance, you've got Android JVM by itself, which means you can run it on desktop, Kotlin native, WASM, which is for web, and GS, which means is JavaScript for also web. So this library that I screenshot, I think it was Coil, they have like everything. You can run it everywhere. Some will have more or less. But they are, for most apps, I would say there's a very good coverage. You can scan this QR code if you want to go on the website. And if you can also remember, it's klibs.io. So if we try to fill the gap, for biometrics, we've got Moco Biometrics, which means you can now use biometrics across Android and iOS. For Firebase messaging, you can use KMP Notifier, which now you can both receive Android and iOS notification too. We've got camera, we've got analytics, media, location, and there are more library coming. And I think it's only going to get better from here. So one of the questions you may have is, can we trust this maintainer? Because when you have your startup or your established company, you start to use new technology, one of the questions is, can I trust the technology I'm using? Because if down the road, nobody is maintaining this library, may have some issues, right? And thankfully, I would say in most cases, yes. So first, JetBrains and Google are premium contributor to Kotlin multi-platform. They provide the key APIs that make a lot of apps working, like we saw the first part with everything that is persistence, networking, UI. They already provide that for you. Google is working heavily on bringing more libraries. And I think just in the last year, they released about 7 libraries. They ported 7 libraries from Android to Kotlin Multiplatform. And then there are other actors like the Cash App and Square, and TouchLab and IceRock. So Cash App and Square, you may have heard of them, or Block, I think it's been renamed. They were the company behind Retrofit and Dagger. TouchLab and IceRock, they are like more agencies. They use multi-platform and they're quite committed to multi-platform, and they release libraries on a regular basis and with updates. And then you have the community. So the community, like Coil, is just maintained by the community, but there are also like a lot of developers working and having interest in developing this. So let's see how Kotlin Multiplatform is in the wild. Who is using Kotlin Multiplatform? Is there any big apps? And yes, there are. Duolingo, like if you want to learn a new language, you may have used Duolingo. And turn out that they are using Kotlin Platform for a couple of years now. They use Ktor for networking, but they also have been smart and introduced new technology or try to think a little bit out of the box. Or for if you use Duolingo, there are a lot of animation. All the characters are moving. There is even haptic now, etc. They have a lot of animation, and for the animation, they use a technology called Rive. And they created some tools across Rive to make the animation work on both Android and iOS. It's been very successful for them, and now they have a KMP first strategy. So anything they are building, they try to think in and use KMP first. And what they are seeing is that they essentially have about 2/3 of their development that is for Kotlin Multiplatform, and then about the remaining third will be half, more or less half Android and half iOS for like adjustments. Maybe like something very specific, or maybe they need to like create their own small library to address a very specific problem they have on both platforms. Another big app that I think everyone is in this room has been using is Google Docs. So Google Docs has a very interesting history about multi-platform because they were kind of multi-platform before Kotlin Multiplatform. They used a Java with a transpiler, which convert the Java code into Objective-C. So that's kind of their history. So what they're trying to do now is they're trying to move away from this transpiler, and they convert the Java code to Kotlin. That's kind of, I think, a little bit strange, and then they use everything Kotlin from that point to release everywhere. And one thing I found very interesting about that is there is a consistency across platform, feature to feature, but also bug to bug. So when you have a bug, you're going to fix it for both platforms at the same time, because they have a single code base in Java. They still write their code in Java. I think they want to move to write Kotlin code at some point, but they convert the Java code into Kotlin, and then they run it everywhere. It's been very successful for them on Google Docs. Performance-wise, it's similar to native. It's either similar or better that they have with the native implementation. They have been running experiment for a few years now. It's validated with Google Docs. And so now they are building that across Google Workspace, slide, sheet, etc. So the last question you may think is, what's the cost for me? Because learning new technology can be a little bit daunting. And here I want to put aside of trying to convince management or iOS because I want to strictly see things from an Android point of view. So you need to learn a new project structure because Android looks what is on the left, and with multi-platform, you have a little bit more complexity. You have your common layer, your Android layer, and if you later you want to adopt iOS, you will have an iOS main or a web main, etc. So that's one thing, a little bit of project structure, but I think it's probably achievable. New libraries, like we mentioned, Ktor, Coin, I think they are the two that if you haven't used them yet, you will really need to learn them. Thankfully, they are very, very similar to both Ktor is similar to Retrofit, and Coin is very similar to Hilt. Coin works differently internally, while Hilt precompile the dependency. Coin does that on the fly, but in terms of performance, it's still relatively similar. And so some benefits you get with using just a KMP tech stack on Android. Little impact on your development time because you already use basically all the tools you know and love. The learning curve is pretty soft, as we saw, just a couple of libraries to learn. It's relatively low risk because you still write your Kotlin code and there is no major change. If you strictly stick to Android, you don't have to convince anyone, right? You, as a tech owner of your app, you can decide to use that and that's it. And then it's gonna enforce a little bit more a better application architecture because you need to like clearly separate the common layer with the Android layer. And then later on, you can decide to adopt iOS, desktop, or web, but you can do it at your own pace and depending on your use cases too. So the first step to move from KMP to so KMP plus Compose multi-platform from a normal Compose app. You need to update the project structure, update the Gradle dependencies because now you don't use Compose from Google, you use Compose from JetBrains. And then you implement some of the actual expect for the Android very specific features. And then you can move your code to the common module. It looks like this. So essentially, you will have your Compose, your Vue MVVM architecture, core routines. You can continue using Room for your persistence, a little bit of learning for Ktor and Coin, and then you can use other libraries for your very specific subject. The latest version was released just a few weeks ago, and it implements a lot of features like on par with what you can find on Jetpack Compose 1.9, which is the latest version. And then they always improve on performance. So with that, thank you very much. I hope I answer the question. And hopefully you can start your Kotlin multi-platform journey from here. You can find me on X. And if you want to download the app, I think the QR code will do it. Yeah, do you have time for questions?
Yeah, we can do one or two.
Sure.
Questions, one here.
I was just wondering what you use for Jetpack data store and encryption.
Okay, for data store, Google ported data store to multi-platform. So essentially, you can use it for encryption inside data store or for outside.
Yeah, particularly in data store.
I don't have the answer from the top of my head. I think it depends also if you want to implement your own encryption or not. If you use the encryption provided, it's cross-platform. But if you want to have your own, then you will have to like build it across, like with actual and expect.
Any other questions? Sorry, one sec.
So I've been looking at this scalibs.io, and I've seen libraries that I wouldn't necessarily think have a platform-specific implementation, like OKHTTP, for example. Why is that? Why is it in multi-platform?
Okay, so some are built in pure Kotlin, which means they can run anywhere. So let's say you just want to do an addition, right? You want to add two numbers. If you want to add two numbers, you don't need any platform-specific code. You can just do an addition, right? So that's why there is no, it is multi-platform, but it doesn't need any platform-specific feature. And a platform-specific feature will be you want to use the camera, and it's this.
So that's the question. Why is OKHTTP multi-platform? Why is it what platform-specific feature does a HTTP client have? Because I could write a socket
Yeah, essentially, this is part of a, there is no system specific. So it is multi-platform by default. So
Okay, so it's just a standard Kotlin library then.
it's just written in Kotlin. And so therefore,
Okay.
there is nothing, it's just going to work. Yeah. There is no, it's not specific. This is why.
Then it's not multi-platform.
Yeah, it is. It's like if you write your code in Java, you can run it everywhere, right? You don't need like a Windows specific. Yeah.
Could I?
Yeah, please.
So, say you build an Android library or a JVM library with Kotlin. When you publish that to make it sensible, you're publishing jar, right? Jars only work for Android or JVM. So if, as a library author, you want to make that functionality available, like the addition functionality, available to other platforms, you also need to publish the compiled native code that can be depended on by Kotlin native, or the compiled WASM bytecode that can be depended on WASM, or the transpiled JavaScript code that can be depended on by the JavaScript implementation. So if you just publish your Android library, even though it doesn't use any platform APIs, that doesn't necessarily mean you can use that on the web or on Melbourne. So you need to write the library and target it. Right. So the native code is for that platform, because HTTP is a business topic.
Yeah, exactly. Because of that, maybe we can take this question out. We can discuss that later. I think other people have other questions.
Okay, in interest of time, we're going to just take one more question
Sure.
and then call it a day.
Just a quick one. When it comes to unit testing, the actual implementations, how does that work compared to like
Very good
how we're
question.
expecting?
So for anything that is in your command module, you can use Kotlin test. For anything that is outside your Kotlin module, which is, command module, which is like either Android, iOS, then you can write your Android specific tests, but you can still use Espresso, you can still use JUnit, you can, in the Android module, essentially, you can use the tools you know already. For iOS, same thing. If you have unit tests specific for iOS, you can use your iOS tool. I'm not like an iOS specialist, so I leave that to you, but yeah.
Awesome.
All right.
Thank you so much, Cedric, for the insightful information on Kotlin Multiplatform.